Hello again, Year 10s. About 4.5 hours ago, I got interrupted halfway through filming a video on the unit circle and the graphs of sine and cosine. And would you believe it, I'm only just getting back to it now. But what I want to do is pick up where we left off. So we looked at basically as a point goes around the circumference, x coordinate is cosine, y coordinate is sine. And we're going to pick up from there and see what would happen if I graphed the coordinate as I traveled around the circle. And to do that, I'm going to click on this little applet here. It's going to pop open in, it should be popping open over here. That's exactly what I wanted to see. So unit circle, and we'll start with the sine graph. So the unit circle, the sine, oh, here we go, it's loading again. It stayed open from 4.5 hours ago. What we're going to do is over here on the right, we're going to sketch a graph of the y coordinate as this point travels around the circumference of the circle. Now at the moment it's on 0 because what's the y coordinate at that point? That's right, it's 0. This is a unit circle, so the coordinates at that point there would be 1 and 0. And we'll just tab back into our spreadsheet here and one note here and think about this a little bit more clearly if it'll let me slide across. Yeah, so we've got the point there that's... Once we get to the top, the x coordinate is going to be 0 and the y coordinate is going to be 1. Over here at the extreme left, the x coordinate, well, I'm 1 unit to the left, so that's -1. My y coordinate is going to be back at 0. And at 270 degrees, around from the positive x-axis, the x coordinate will be 0 and the y coordinate will be -1. And then the point's going to continue traveling around here until I get back to an x coordinate of 1 and a y coordinate of 0. So I can plot in some of this information already. If we think about this as being 90 degrees, 180 degrees, 270 degrees, and 360 degrees, well, the y coordinate is definitely going to start at 0. By 90 degrees, the y coordinate is up at 1. At 180 degrees, the y coordinate's back down to 0. At 270, the y coordinate is -1. And at 360, we are back to where we started. Now the question is, how do I fill in those lines? Is it a straight line between each of those points? Should it be curving up like that and down like that? Does it go this way and that way? Does it vary? We want to know how we should be joining up those lines. I need to change that eraser back to the stroke eraser. That's going to make it a little bit easier for me to get rid of everything. And so let's think about it. Let's just break this up into 30-degree segments. Now I'm estimating here, but they seem roughly equal to thirds. Maybe that top one's a bit skinnier. It's a bit hard to tell perfectly. Look at the change in the y coordinate in each of those 30-degree segments, assuming that they're all equal. In the first 30 degrees, there is quite a large change in my y coordinate. In the next 30-degree increase, the change in the y coordinate is significant, but it's not as significant, is it? And what about in that last 30 degrees? Well, there's really very little change at all in the y coordinate. Initially in this quadrant, the motion is mostly vertical. Then it's roughly vertical and horizontal in equal measures. And in the last 30 degrees, it's really changing horizontally, but the vertical position of the point doesn't change very much. What would that look like? Well, let's plot these points. That 30 degrees I'm suggesting is about 1/2. So if I was to break this 90-degree section up into 30 degrees, I'm already going to be at 1/2 by the time I get to 30 degrees. 60 degrees, well, I've got the point there. I think it's going to be about here somewhere. And then we're going to hit 90. So if I was to join them up in a smoothish curve, we're going to make a prediction here of roughly what we think it's going to look like. It's going to look something like that. Maybe it'll flatten out a little bit more at the top there. But that's a reasonable estimate from my point of view as to what it's going to look like. What do we notice as we go into the next quadrant though? Well, if I broke it up into the same 30-degree components, the heights, remember we just looked at the fact that the sine coordinate the sine of an angle is the same in quadrant 1 and quadrant 2 if the reference angle is the same, the distance from the closest x-axis. So all of these are going to have corresponding points at the same height. So if I'm going to put another 30 degrees, that'll be 120. At 150, I know I'm going to be back at a half. This one here, we were sort of estimating it was about that high. And we can get the familiar pattern. It should be symmetrical, the first 90 degrees and the second 90 degrees. What's going to happen is I go down into the third quadrant, and you can see why it gets a bit confusing if you just look at those images that we have from the textbook. This time, again, this distance, this vertical distance, is going to be equivalent to that vertical distance. They're going to be the same length, but it's in the negative direction. So if I was to go to 210 degrees, I want to be at negative 1/2. At 240, well, we want to be at whatever height that is. We will learn what that height is. It's about here. And then, again, it's going to be symmetrical in that fourth quadrant. And if I continue to plot the y-coordinates, there's 300, 330, that's the one that's going to be at a half. The other one's going to be fairly steep. We don't know the exact value of that yet, but we'll get to that. So that's my prediction based on just a few points, looking at the y-coordinate, how it's changing. Closer to the x-axis, most of the change is vertical, so the graph is steeper in those sections, near 180 degrees and near 0 and 360 degrees, steeper. When I'm near the top and the bottom of my unit circle, the change in y is quite gradual. It's only a small decrease for that 30 degree section. It's only a small increase in that 30 degree section. So it's flatter there, and in fact right at the top it's perfectly horizontal. It is flat. So that's my prediction for what it's going to look like. Let's go back to the app and see whether or not that's the case. So all you do is you grab this angle and you slide it along. And you can see it's increasing the angle there and showing us the y-coordinate increasing. Let's go back. We said 30 degrees was going to be a half. Now I knew that already. But that was also what it looked like when we were just estimating the value. 60 degrees, we said it was a fair bit higher. How high was it? It's about 0.87, 0.866. So that's fairly high. And so that last little increase to get to 1 is going to take the next 30 degrees. It's not until I get to 90 that it's going to get to 1. So you can see the increase in the y-coordinate as I go up by a degree is now quite small until eventually I get to 1. In the next quadrant, it's going to be symmetrical. It's going to repeat the pattern, but it's going to be decreasing instead of increasing. Then we go into the negative values. The y-coordinate, you can see the y-coordinate on... Whoop. It doesn't like me pointing with my stylus. Maybe if I hold it just above. No, it doesn't like that either. You can see the y-coordinate, the little red line, increasing as I drag that angle along. Well, now it's zooming. Don't know how I managed that. Extra skill. Click out of it, click back into it. And you can see then it goes back up towards the 360. Now this is only showing one rotation. I could go round and around, and that graph would continue following the same pattern all the way across. So that's the sine graph. We can see what it looks like. We can see it's mapping the y-coordinate. At the start it's 0 degrees. And the y-coordinate is 0. It increases all the way to 90 degrees where it hits its maximum of 1. Then it decreases back as we get to 180 degrees, it gets to 0. Then we go into the negative values. We're below the x-axis now, so the sine graph is below the x-axis too, showing all the negative values until we get back to 360 degrees, it's back to 0. And that's the basic shape. And that continues in either direction. If I did negative angles, it would continue back this way, following the same pattern. Alright, that's our sine curve. Let's think about our cosine curve and see if that would be the same or different. A little bit of erasing to do here. Thankfully it won't take us long. We're going to use the same idea of the 30 degree gaps, but we don't want to be moving across to our y-axis, do we? Because cosine has nothing to do with the y-coordinate, it's to do with the x-coordinate. It's going to be easier just to delete all of it, I think. Or at least enough of it so that it's not so busy and confusing. Alright, we used red for that one. Let's use a different colour. Purple it is. Alright, so we're going to break it up into the 30 degree sections again, roughly estimating. And we can do that all the way around now if we like. If you've got a protractor, you could do this on some graph paper and actually get yourself a really accurate one. You can also create it in Desmos if you want. There's lots of things you can do here. Now I'm interested in the x-coordinate. At 0 degrees, well, the x-coordinate is 1. So I know this graph for cosine x is going to start at the top. It's going to start at 1. When I'm at 0 degrees, the x-coordinate is 1. What's going to happen as I move the point around the circumference until I get to 90 degrees? Well, at 90 degrees, the x-coordinate is going to be 0. At 180 degrees, I'm as far left as I'm going to go. I'm at -1 is my x-coordinate. So cosine is going to be -1 if the angle's 180 degrees. At 270, as I come through this quadrant, the x-coordinate, the point, is moving back along the x-axis until when I'm at 270 degrees, the x-coordinate is back to 0. And then as I move through the fourth quadrant, the x-coordinate's increasing all the time. I'm moving further right, and I get back to 1 at 360 degrees, which I somehow managed to rub out. Again, to get an idea of the shape, are they straight lines? What sort of shape are they going to have? You've probably already guessed the curve by now, but let's have a look and see if we can make sense from our unit circle as to why it's the case. I'm going down to the x-axis now. Some of the change in the x value in the first 30 degrees is very small, isn't it? In fact, we know it's going to drop from 1 to about 0.866 because we saw that just a second ago. So at 30 degrees, we're still way up here somewhere. By the time I get to 60 degrees, I'm down to a half, and then the rest of it drops away really quickly. At 90 degrees, I'm back to 0. So that first little section is going to have a curve something like that. Obviously, I'm having a little bit of trouble drawing on the screen there, but you get the idea. Through the next quadrant, well, it's going to have the same differences, but they're going to be negative because over here, the x-coordinate, if I follow that point down to the x-coordinate, it's a negative value, isn't it? And I follow it down to the x-coordinate. You can see I didn't put that one in the right place because we know that one's at a half. And here it's dropping down again. So what's going to happen is every 30 degrees it's decreasing, but it decreases quite quickly at first. It's going more negative quite quickly. In the last 30 degrees, it's only a small change. You can see that first change quite big, the second change quite small. So we end up with the same sort of shape. And of course this is symmetrical, so as I go back through the next quadrant, we're going to have a small increase in x, then a larger change in x, and eventually the last 30 degrees in quadrant 3 is the largest change. So what does a large change correspond to? A steeper graph. And then in the fourth quadrant, the x value is increasing again quite quickly at first, not quite as quickly, but still fairly quickly, and then quite slowly comparatively in the last section. So you can see where it's not increasing by as much, it's a flatter shape in the curve. And that is our cosine graph. Y equals cosine x. Let's watch it again with the applet and make sure we can see how that works. So I just click on the next one down here, sine and cosine graph. I'm going to start at 0. So you can see the x-coordinates. So now this length of the pink line is going to be the height that we show here. So at 30 degrees, 0.866, that's going to be an x-coordinate of 0.866. We plot it there. In this case, we plot the x-coordinate as a y-coordinate when we draw the graph. That's the only bit that sometimes people get confused about. As I continue, the x-coordinate's getting smaller. As the point moves around and gets closer to 90 degrees, the x value, the x-coordinate is decreasing until eventually, at 90 degrees, that corresponds to an x-coordinate of 0. Going into the second quadrant, my x-coordinates are going to be negative, aren't I? As this yellow point moves around the circumference, the x-coordinate of it is going to decrease all the way until it gets to -1 out here at 180 degrees. Let's see if that happens. Yep, at 180 degrees, the x-coordinate is -1. So my graph shows that. And then as I come back, the x-coordinate is going to increase. For the next 180 degrees, it's increasing all the time. Slowly in that first little section, not much of a change in the x-coordinate. More quickly around this section because it's mostly horizontal, the change in the circle there. And then slowly again as we get towards the end. So it's going to be slowly, so it's fairly flat. It gets steeper and steeper. It's now changing it as quickly as it's going to, and then it starts to slow up again until we end up with that. So that is how you go about drawing your sine and cosine graphs from your unit circle. That's 15 minutes. I think that's enough for this one. I will catch you. I might make a third video for this if you're really keen to stick around and learn some more, but that should be enough to get you started with the exercise. Well done, guys. Good luck with all your work. Cheers.